All right, we're at section 21.5, gasoline and diesel engines. Um, let's look at the this graph here, and let me remove the my image so as not to interfere. Uh, this is a four-stroke engine. There's four strokes in two events, and you'll see the strokes. There's an intake stroke, a compression stroke, a power stroke, and an exhaust stroke. And there's two events: the spark event and the release event. And we'll take a. You can see this dotted line here is the extremes of the top surface of the piston. So you can see it here at the very extreme bottom. This is uh, where that dotted line is, and you can see at the very top of it where the spark is ignited. Uh, that's uh, the top extent of the piston moving. So let's go through this, and they have PV diagrams to go alongside each stroke and event. So we start with the basically it says O to A from V2 to V1. The volume is increasing. So the intake valve opens and the air fuel mixture enters as the piston moves down. Now this is all at atmospheric pressure. So you have the air and fuel mixture coming in here as the piston moves down, and it draws the air and fuel mixture in. This is the intake stroke. Then you have the valve closes. You see back here, the valve was open, and that's letting the air in. Here, the valve closes as the piston continues to go around. There's a little flywheel that allows the piston to move. And if it's a multi-cylinder piston, then you have other pistons that are doing work at the same time. So the piston moves up and compresses the air mixture. So there's a compression here. This is from A to B. That's along this line. You can see that the it's not isothermal. Uh, the the volume is decreasing, the pressure is increasing, and the temperature is increasing. Um, so those are all in the compression stroke. And then you have an event, the spark plug fires and ignites the mixture. And that's the B to C. So you can see that uh, uh, the in this little short time, the volume hasn't changed, but the temperature has increased. That's the B to C. That's the spark. The temperature increases and ignites the gas, raising the temperature. That's the B to C portion of this PV diagram. And then the hot gas pushes the piston downward. So the volume, again, goes from V2 to an increased volume of V1. And it's an adiabatic process. And so that's where the actual work is done, the power stroke. That's where the ignition pushes the piston downward. And you get this uh, the work is done in this stage. Then you have a release event where the exhaust valve opens. You can see the valve on this side opens, and the residual gas escapes, and that's in this D to A. And then the cycle begins. So the piston moves up and pushes the remaining gas out, and now we're back to the beginning, and it's just a cycle. And so um, also called let's see, the Otto cycle is I think is that the um, let's see, I lost my place. Um, so if the air fuel mixture is assumed to be an ideal gas, the efficiency of the Otto cycle is one. Um, the efficiency is 1 minus 1 over V1 divided by V2 to the power of gamma minus 1. That's so V1 and V2 is the compression ratio, and gamma is the ratio of the molar specific heats, CP over CV for the air fuel mixture, which we studied in the previous chapter. Um, so now diesel engines operate on a cycle similar to the Otto cycle, but they don't employ a spark plug. The compression ratio for a diesel engine is much greater than that for a gasoline engine, and the air in the cylinder is compressed to a very small volume, and as a consequence, the cylinder temperature at the end of the compression stroke is very high. At this point, the fuel is injected into the cylinder. The temperature is high enough for the air-fuel mixture to ignite without the assistance of a spark plug. Diesel engines are more efficient than gasoline engines because of their greater compression ratios and resulting higher combustion temperatures. And sometimes gasoline, I don't think they do it much anymore, at least I don't remember them, but older gasoline models, they would begin dieseling on their own where you would turn off the engine, but it would continue to run. Um, let's see, and that's the end of the 21.5, the gasoline and diesel engines.